Good evening to everyone. This is Empress System Basics and Application. In this chapter, we are going to see what is meant by the system, what is the embedded system, what are all the components of embedded system, and what are all the classifications of embedded system, and what are all the processes can be used in embedded system. Then what are the other hardwares we are using in the embedded system, and the softwares we are using for the embedded system, and what are the main real-time applications of the embedded system. Introduction. In general, what is a system? A system is a way of working, organizing, or doing many tasks according to a fixed plan, a program, or set of rules. A system is also an arrangement which all its units assemble and work together according to the plan or program. These are the examples for the system. A simple wristwatch is an example for the system. It shows the time in a display. What are all the parts inside a watch? A hardware, a needle, a battery, and dial. We are also having chassis and strap. Rules in general, in the clock, all the needles are moves in clockwise only. A thin needle rotates every seconds. A long needle rotates every minute. A short needle rotates every hour. All the needles return to the original position after 12 hours. Another best example is washing machine. We are having washing machine in our home. What is the purpose of washing machine is to clean our clothes. And these are all the parts available inside the washing machine. A status display panel, switches, dials, motors, power supply, control unit, and water level sensors and solenoidal valve. In general, for the washing machine, we are following these rules. By putting the cloth, we are used to wash the cloth by the method of spinning, rinse, drying. After that, we are wash over by blinking, and each step display can be shown at the each process stages. This is the display. What is mean by an embedded system? Embedded system is that one has computer hardware with software embedded in its one of its important component. The embedded system shows the software along with the hardware. That is the main criteria of the embedded system we are following. In general, a software program only decides the system will be used for which application, and the softwares can be embedded in read-only memory, and it does not need secondary memories in the computer in general. These are all the computer hardwares. The computer hardware, you are seeing the RAM, keyboard, monitor, mouse, printer, scanner, and the Ethernet card processor. These are all the hardware parts of the general computer. And in this computer, we are having a main part that is a microprocessor that only decides which application and which processor we are going to decide for the computer. and a large memory. In general, computer and laptop having a large memory in terms of gigabytes. That large memory is having it is having two types, that is primary memory and secondary memory. The RAM and ROM coming and under the category of this large memory, and also in case of internet we are considering cache memories. We are having input units in the computer hardware, that is keyboard, mouse, scanner, etc., and the output units, monitor, printer, etc., networking units, that is ether card and drives, and IO units, which is belongs to modem, fax, modem, and fax devices are coming under this category. Components of embedded system. It is having a hardware and it has a main application software. It has a real-time operating system. These are all the characteristics of the components of the embedded system. In the hardware, we are having processor, timers, interrupt controllers, IO devices, and the other accessory parts. In the main application software, we are going to decide which application software we are using for the particular application. In general, we are following C, C++, and high-tech C for the application software in case of embedded system. In addition to that, embedded C is one of the software we are going to use. Nowadays, we are also following Python and other softwares coming in the decades we are following. And we are having a real-time operating system. The real-time operating systems are of various types. We are following the real-time operating system in general for system. For our computer network, we are following Windows and Linux, Unix, and also we are using VxWorks for the real-time application in the operating system. Embedded system hardware, it shows the layers of the embedded system hardwares. It is the main in a circuit board shows a power supply and oscillator circuit, and the output circuit board shows system application specific software circuit, that is system application specific circuit. In this we are having input devices, that is the interfacing devices and driver circuits. In this, from the interfacing devices and driver circuits, we are going to connect a processor, a program memory and data memory, and timers, serial communication ports, interrupt controller, parallel ports, and output interfacing and driver circuits. Embedded system constraints. Embedded system is a software designed to keep in three constraints. First one is available system memory, available processor speed, the need to limit the power dissipation. These are all the main three constraints we are going to take a embedded system for a particular application. When running the system continuously in cycle, we are going to have an event, that is run, stop, and wake up. What makes the embedded system different? These are all the factors that making the embedded system different. The main factor is real-time operation. The next one is size. The size is very important factor, and also cost. Then we are mainly considering the reliability of the system. Apart from time, we are considering the reliability of the system. The main factor we are going to consider the security. That is, without security, the system will not be a good one. So we considering the security as a factor for the embedded system, because all the all the computer systems are hackable. So we consider some safety measures, that is security measures, to avoid excess threat to theft our softwares and other. So we consider the security system. These are all the classifications of the embedded system. Small scale embedded system, which shows a small scale applications. That is, we are having only a simple application for the specific device. For example, timer. The students which are doing timer circuits as a project is also coming under the small scale embedded system, and also a small production devices which are coming under the category of the embedded system are also coming under the small scale embedded system. Next one is medium scale embedded system. It is coming in the public use, and we are considering the scanner, that is IR scanner and QR code scanner are all coming, barcode scanner even are coming under the category of medium scale embedded system. Then sophisticated embedded system. The sophisticated embedded system is applicable in the industrial side. Industrial side, for particular application we are following a particular system. The PLC, programmable logic controller, is also coming under the category of the sophisticated embedded system. And automotive software systems we are using in the company are coming under the category of sophisticated embedded system. These are all the IC chips for the example. First one is a PIC microcontroller. Then next one is the medium scale we are following Atmel system. Then the sophisticated embedded system, we are having a separate motherboard having a software that is similar to a computer. Small scale embedded system, small scale embedded system showing the following characteristics. That is, it is single 8-bit or 16-bit microcontroller. Yeah, it is having some little hardware and software complexity, but it is easily we can program the system. So it is not coming under the what do you say, full problematic system. It is only a simple system. We easily do the programs, and we easily erase the program, and we can store the program, and it may be even battery operated. And usually C is used for developing the system. I already told embedded C++ are used for the embedded system programming. There is a need to limit power dissipation when system is running continuously. This is the main drawback in the small scale embedded system. We have to limit the power dissipation, so we will use the system for a particular time. Programming tools we are using are editors, assemblers, and cross assemblers. In general, we are using the MASM, that is a software for microcontroller based systems, and for the hardware based system, that is we are coming under the, when we are going to the higher application systems, we going for Arduino board, and also we are going for the Keil software. These are all the programming tools we are following for the small scale embedded system. Medium scale embedded system, it is in the range of 16 or 13-bit microcontrollers. Or in general, in this medium scale embedded system, we are following a digital signal processor, and we are following the reduced instruction set computing, because we know in general microprocessor and microcontrollers, even embedded system controllers, having higher end applications. When we are using the number of commands and number of mnemonics high, then it will not be easy for us to program. So we use the reduced instruction set computing. Then we will reduce the mnemonics, and when we will reduce the instruction sets, then we can do the program easily. Then It is having both software and hardware complexity compared to the small scale embedded system. These are all the programming tools we are following. For the programming tools, we are considering RTOS, that is real-time operating system, source code engineer tools. The source code engineer tools coming under the higher end application for a particular for a particular system or particular real-time application. Then a simulator, debugger, and integrated development environment. That is IDE. Sophisticated embedded system. In sophisticated embedded system, enormous hardware and software complexity compared to the medium scale embedded system because it is used in the industrial side. It is the real tough one we are going to when we are going under the design category. The enormous hardware and software complexities, then which may need a scalable processor and configurable processor and programming logic arrays. It is having a scalable processor or a configurable processor or a programmable logic array. In general, for industrial side, in electrical, we are considering the PLC, programmable logic controller, and also we are going for some big processors using that we are using the big processors like that what do you say power line carrier communication and SCADA, power line carrying communication and SCADA, which may be a scale with a scalable processor and programmable logic arrays. In power line carrier communication, we are having number of constraints. So we must give a logic for a, each processing devices. So we are going for programmable logic arrays in case of power line carrier communication. And in SCADA, we are going to calculate the signal level and range. So we must give the scalable processor for the SCADA and the constraint by the processing speed available in their hardware units. The hardware units is mainly depend upon the speed of the system. In general, for this programming tools will be depend upon a separate programming tool which is confidentially maintained by the each companies. And we in general we are for the power line carrier communication and SCADA in the power grid we are following Homer Pro as a software which is available in free and also in payable version. Next one is what is mean by a processor. Processor, in the what is mean by a processor. A processor is the heart of an embedded system. In embedded system, for embedded system designer, he must have a knowledge of microprocessor and microcontroller. Then only he will design a processor for the particular application. So the knowledge of microprocessor and microcontroller and its program knowledge is all essential for the embedded system designer. The two essential units we are having is control unit, which is doing the operation of fetch. Next one is execution unit. The control unit is used to take the instruction from the processor. The execution unit is used to execute the instruction from the processor. So the control unit is coming under the input of the processor. The execution unit is coming under the output of the processor. The various processors are general purpose processors, In general purpose processor, we are having microprocessor, microcontroller, embedded processor, digital signal processor, and we are having another set of processors that is called application specific system process and multiprocessor system using GPPs. These are all the categories of the embedded system process. We are going to see the microprocessor. The microprocessor is a single chip semiconductor device which is used in a computer but not a complete computer. It is a processor, not a motherboard. So the microprocessor is a part of the motherboard. It will decide the computer operation. So it is not a full controller for that particular system. In general, CPU, about the computer, the same computer operation we are considering for the microprocessor. The computer architecture is coming under the same of microprocessor. In that microprocessor we are having, that is the microprocessor having a part that is called central processing unit, having arithmetic logic unit, program counter, stack pointer, and working registers. Along with, we are having a timing circuit, that is clock timing circuit, interrupt circuit on a single chip. To make a complete microcomputer, one must add a memory, usually a RAM or ROM, memory decoder, and an oscillator, and number of serial and parallel ports. The history of microprocessor, the first generation we are having 4004, that is the microprocessor with the pin with a number that is called 4004 and 4040. It is under the first generation. The next one is 8008, 8080. Then the third generation is 16-bit processor, that is 8086 and 8088. In the second generation itself, we are having 8085, that is 8-bit microprocessor. In the third generation, we are following 8086, 16-bit microprocessor for our basic applications. And it is followed by a, what you say, that is a generation of processor in the third generation, that is they are coming under the category of the updation of the processor, that is 80186, which is the advanced version of 8086, and 80286, 80386, 80486. The 80186 and 286 coming under the 16-bit processor, and 80386, 486 coming under the 32-bit processor. Apart from this, we are having a Pentium processor, that is 64-bit processor, which is available in our computer. The Pentium processor not manufactured they are only not manufactured for the computers. They are only manufactured for their specific application for the processors. And 8086 and Pentium processor have all been designed for use a personal computer type application, have large memory maps. In what do you say, in the third generation only, we are having a desktop computer. The desktop computer showing various applications with the use of the Pentium processor. It is decided from the 8086 processor. Now, these are all the upcoming, not upcoming, it is the, what you say, the fourth generation or third generation process, fourth generation or fifth generation process, that is Intel 4004, Intel 4040, Intel 8080, 8085, 8086, 8088, 80186, 80188. These are all the categories of Intel processor. And another one is Motorola. It is also a company which manufacturing the same operation and application based on the Intel process. 6800, 6809, 68000, G3, G4, G5. G3, G4, G5, it is not a mobile phone. It is generation 3, generation 4, and generation 5 process they are following. Zilog, it is also a company which are manufacturing microprocessor, that is Z80, Z180, EZ80, Z8, EZ8. And there are more number of companies. We know company Atmel, they are manufacturing the some type of microprocessor based on that Intel process. Then microcontroller is a functional computer system on chip. It contains a processor, memory, and programmable input and output peripherals. A microprocessor and microcontroller. Microprocessor is a single chip having a specific application only for programming. But microcontroller is different. It is consist of memory, a processor, and programmable input and output peripherals. In case of microprocessor, it is only doing a program. But microcontroller doing a program, getting a value, doing a program, and giving the output. So it is consist of all the input and output peripherals in a single chip. Microcontrollers include an integrated CPU, that is, it is having the CPU consists of memory and peripherals and input and output devices. Various microcontrollers are Intel 8031, 8032, 8051, 8052, 8751, 8752. And in case of PIC microcontroller, the PIC microcontroller is the PIC application controllers we are following in electrical, electronics, and various industrial sites. PIC microcontrollers, it is coming under 8-bit category and 16-bit category. For the 8-bit, we are having PIC 16 and PIC 18. For 16-bit, we are having digital signal processor, that is DSPIC 33. The DSPIC 33 is the advanced version of PIC controller. They are using the technique of digital signal processing. It is having DSPIC 33 and DSPIC 24. Then PIC 16C7X, it is the upcoming updated version, that is the updated version of the PIC DSPIC 33. And the companies, that is Motorola, is also manufacturing the microcontrollers, that is MC68HC11. It is used for a specific application, that is what you say, we are having a thumb scanner and fingerprint scanner are all coming under this microcontroller application. Then what do you know, microprocessor and a microcontroller, what is the difference? In microprocessor, we are having a functional block of ALUs, registers, and control units. In case of microcontroller, we are having a functional blocks of microprocessor, including, in addition to that, we are having a timer, parallel input and output devices, RAM, EEPROM, and ADC and DAC, which is not available in the microprocessor. In this microprocessor, the bit handling instruction is less, so it is having lesser number of instructions and it is having lesser number of mnemonics. In case of microcontrollers, it is having more number of instructions. Many type of bit handling instructions we are having in the microcontroller. In case of microprocessor, we are having rapid movement of code and data between external memory and microprocessor. In case of microcontroller, the rapid movement of code and data within the microcontroller. But in case of the microprocessor, it is having the separate memory, so it is moved from the microprocessor and moved to the external peripheral devices, that is external memory. The next one is, it is used for designing general purpose digital computer system. It is the microprocessor only is applicable for 8-bit or 16-bit system with general purpose application. Then microcontroller, we are having uh, various application, that is specific application for a specific system, that is equivalent to embedded system. Before embedded system project, embedded system products came to the market, microcontroller is the base to design my microcontroller is the base to design a embedded system products. It is used for a specific application and a specific programming, so it will given a specific line for the embedded products. Embedded processor. The embedded processor, what you say, it is a special microprocessor and microcontroller. So it is often called as embedded processor. It is different from microprocessor and microcontroller. The embedded processor is used when fast processing, fast context switching, atomic ALU operations are needed. What is mean by fast processing and fast context switching? In various areas, you see for any application, we don't wait for a time. So we need to do any work within a time. For example, when we are going to the ATM machine, we are inserting a card and type what are all the details the ATM machine asking, that is pin number, and what are all the amount you going to earn from the you're going to take from the machine. So for this, we are going to set a particular time. We don't wait for the time and wait for the time to take the money. In previous days and previous years, what without ATM, what we are doing is we are waiting in the bank and we're taking the money from the bank by simply waiting for 2 to 3 hours or even one day to get the money from the bank. But in case of ATM, we are not waiting. We are having the fast processing, and we are taking the money with a fast context switching, that is within a single simple fraction of time, we are typing the amount and getting the money within a fraction of time. Next one is atomic operation, ALU operation. That is atomic ALU operation means we are doing the work with a specific manner, that is specific arithmetic manner, that is in case of all the applications in embedded processor. For embedded processor, we are having the examples, that is ARM processor. The ARM7 is a, what do you say, it is a beginner processor of the embedded system. Then Intel i960 and AMD 29050. These are all the applications of the embedded processor, that is application based embedded processor in the embedded system. Okay. Digital signal processor. The digital signal processor as, what do you say, the general purpose processor, that is called GPP. I forgot to mention. It is a single chip VLSI unit. It includes computational capabilities of microprocessor and multiply accumulate units. That is, it will convert all the operations into a easily accessible units, that is called multiply and accumulate units. DSP has large number of applications such as image processing. What is we are having large number of applications in large number of areas, especially in audio and video applications, telecommunication processing systems, and so on. So it is used when the signal processing function are to be processed fast. What in the signal processing functions, we need, what we say, we need a faster system for the fast doing of the work. So We are for the signal processing applications, we are generally having a VLSI unit. We are having a VLSI unit which is easily divide its operation to do the signal processing applications. For a in the digital signal processor, these are all the processor we are following in the real-time applications. TMS 32TC XX Shark is a processor which is used in the what do you say in a telecommunication and transmission side applications. And Motorola 5600XX, it is used in the various audio and video visual applications systems. Next one is application specific system processor. In the application specific system processor, we are having a dedicated specific task for a faster solution. Because in the industrial side we are only having a specific application for running a particular task for a particular period, so we need a specific task provides with the faster solution, so we are going for application specific system process. Application specific system processor. In application specific system processor, that is we are using in the additional processing unit for running the application in place of using embedded software. That is in the industrial side. The examples of application specific system processors are IAM 7100 and W3100A. These are all the main process we are following in application specific system processor. Apart from this, there are more number of processors are also coming in the application specific system processor. Multiprocessor system using GPPs. Application specific system processor only applicable for one or two systems. For more number of application, we are going for the multiple process system using GPPs, that is general purpose process. And for this, the single processor is not sufficient to do the operation. So for multiple operations, we have to synchronize all the operations with the optimum performance. So we go for the multiprocess system. The Moore's law is used to describe a long-term trend history of computing hardware. This is the base for selecting a particular processor for a embedded system hardware and computer hardware. Since the invention of the integrated circuits in 1958, number of transistors can be replaced extensively by integrated circuits. In what do you say, in the first generation we are having a number of transistors by which shows the entire system will be a big one that can be reduced by using the integrated circuits and VLSI designs. வாங்க. Digital electronic devices are also linked with the Moore's law. That is, they are mainly depending upon the processing speed, memory capacity. Apart from the basic application of the processor, we are having other hardware devices which is mainly used for the embedded system. Without this, the embedded system doesn't operate. It is mainly the power source, clock oscillator, real-time clock, reset circuit, power up reset, watchdog timer reset. The watchdog timer reset is the main one. Without that, we will not reset the particular processor. Then next one is memory. Without memory, we will not store the particular data or file. And IO ports, IO buses, interrupt handler, DAC and ADC. Without ADC and DAC, we will not convert the particular signal for the particular application. LCD and LED displays, keyboard and keypad. Softwares. These are already told we are using C, C++ as a software. And also, apart from this, we are having .NET. Even Java is applicable for the application of the embedded system. The compilers we are using generally RIDE, Kale, and also Omron. Omron is also a compiler which is used for compiling the softwares for embedded system. The simulators we are using in general for microprocessor and microcontroller, we are using MASM, that is Assembling Assembling Language Program, that is MASM. Microsoft Assembler is also another name. Microsoft Assembly is a name we are following. In this Microsoft Assembler, we are doing a simple mnemonic program to do any application for any output. Applications of the embedded system, we know it is used in the real-time application like household appliances, audio players, integrated systems, aircrafts, missiles, cellular telephones, electrical and electronic motor controllers in case of industrial sites, engine controllers for automobiles, calculators, medical equipments, video games, digital musical instruments, and so on. So within this, I conclude this session. What we going to learn by doing Excel through the experimentation, learn by example, acquire skill and get employed, update skills and stay employed. Thank you.